Bearings are mechanical components used to support and facilitate the rotational movement between two parts of a machine or device. They are designed to reduce friction and wear during movement, allowing a smooth and fluid rotation. For this reason, it is crucial to carry out periodic supervision of their condition using a qualified technician. In the event that components need to be replaced, it is essential to identify them precisely to ensure they are perfectly suited to the particular needs of the machine. Since there are many variants, each with its own peculiarities, careful selection is crucial. In this situation, the JACE maintenance technician is dealing with the need to repair an electric motor which, due to many hours of work, has suffered bearing wear, which are now in a condition of high friction and a reduction in overall efficiency of the motor. After dismantling the worn bearing, what stands out here is the presence of shields on both sides, which prevent the rolling elements inside from being seen. These shields are an optional component designed to protect the bearing from dust and other components. However, this feature makes it difficult to identify the exact type of bearing just by looking at its shape. Therefore, in order to determine the bearing, it is necessary to refer to the initials usually found on the side of the rings. These initials are commonly stamped on the metal and are part of a designation system consisting of a series of numbers and letters, which provide crucial information on the type of bearing and the other technical specifications useful for its identification. Each bearing manufacturer uses its own codes to identify its products. However, there is one part of the code that is part of a system used worldwide called the Basic Designation. It reveals through a series of digits the simplest and most important data of the bearing, which are its type and dimensions. In this bearing, we can read 60112Z. The initial number, 6, indicates single-row deep groove ball bearing, the most common type. Here, in this legend, all the numbers and letters you might encounter are detailed, allowing you to recognize the different types of bearings. The following figures identify the overall standardized boundary dimensions according to ISO general plans. The second digit, in this case subscript 1, indicates the width of the radial bearings, which are, as seen in the drawing, dimensions B, C, or T, or the height in axial bearings, dimension H. The width series for radial bearings are the numbers 8, 0, 1, 2, 3, 4, 5, and 6 in ascending dimension order, while the height series for axial bearings are the numbers 7, 9, 1, and 2, again in ascending order. The third digit identifies the bearing diameter, dimension D. The diameter series are numbered 7, 8, 9, 0, 1, 2, 3, and 4 in ascending order of outside diameter. As can be seen, these boundary dimensions are numbers that do not correspond to actual quantities, but are standardized dimensions based on the diameter of the inner bearing bore, the only measure expressed. As a matter of fact, the last numbers symbolize the diameter of the bearing bore, i.e., the inner diameter of the inner ring. This information is fundamental, as it is the dimension that must be adapted to the shaft to which it will be connected. Bores with dimensions between 20 mm and 480 mm are identified with a two-digit number. To obtain the actual bore size, it is necessary to multiply this number by 5. In fact, on this bearing, the code 6011-2Z identifies a hole diameter of 55 mm with the number 11, as we can also see by measuring it with a caliper. The 10, 12, 15, and 17 mm bores are an exception, because they are referred to by the codes 00, 01, 02, and 03 respectively, while, generally, the diameter is explicitly indicated in millimeters and can be separated by a slash in situations where the holes are small, equal or less than 9 mm, for those of large dimensions, equal or over 500 mm, and when it is a size not divisible by 5. This compliance with ISO standards is essential to ensure interchangeability between the various bearings. In fact, bearings conforming to ISO standards having the same bore diameter and belonging to the same size boundary dimensions have identical overall dimensions even if they are a different type. It is important to notice that the codes may slightly change from one manufacturer to another, but the main parts of the naming system generally remain the same. Additional code parts may provide information about the bearing design, such as the arrangement of balls or rollers, the types of cage used, or other specific bearing features. For example, in our bearing 6011-2Z, 2Z is a suffix indicating the presence of the two sheet metal screens on both sides, a very common feature, but which could also be referred to as ZZ or 2ZR, depending on the criteria of the bearing brand. Another easily found suffix is the internal clearance. The internal clearance of bearings indicates the radial or axial displacement between the rings, which is necessary for the correct rolling of the parts, so that deformations during assembly or thermal expansion during operation do not affect the life of the bearing. The various classes are usually identified by codes such as C2, C0, C3, C4, or C5. On the scale, C0 or Cn denotes normal internal clearance, C2 denotes lower clearance, while the other classes represent larger clearances than C0. Therefore, bearing part numbers are crucial to identify the exact type and size of bearings needed for a specific application. It is always advisable to refer to the manufacturer's technical specifications or consult an expert such as Jay's during the purchase process to identify the best available alternative. If you found this video useful, let us know by leaving a like and a comment. You can also share it, and don't forget to subscribe to our channel. We recommend you visit our website, jayscompany.com, to find out about our upcoming projects.